Welcome to Fortinet SASE Administration. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. In this comprehensive presentation, we will explore the FortiSASE 25.3.148 Feature Administration Guide from Fortinet. FortiSASE represents a significant advancement in cloud-delivered security services, combining the power of FortiOS protection with the flexibility of software as a service delivery. FortiSASE is designed to address the security challenges of modern distributed workforces. As organizations increasingly adopt remote and hybrid work models, securing endpoints and user traffic regardless of location has become paramount. FortiSASE solves this by ensuring that remote off-net endpoints receive the same level of security protection as when they are on the corporate network. The service operates through a subscription model based on the number of users, making it scalable and cost-effective for organizations of all sizes. It works seamlessly with various FortiCloud services in the background to deliver a unified security experience. Throughout this presentation, we will cover the fundamental concepts, deployment modes, security features, and administrative operations that make FortiSASE a powerful solution for secure access service edge requirements. FortiClient Agent-Based Mode. Let me explain the FortiClient Agent-Based Mode, which is one of the two primary deployment methods for FortiSASE. In agent-based mode, endpoints connect to a FortiSASE tunnel to secure their traffic. Once provisioned, clients maintain an always-up tunnel connection that ensures FortiSASE continuously scans all traffic destined for the Internet. Looking at the architecture diagram, the flow begins with the administrator who provisions the FortiSASE environment and configures security policies. The administrator also manages user provisioning and sends invitation emails to end users. The end user receives the invitation and downloads FortiClient to their endpoint. Using the invitation code, the FortiClient connects to FortiClient Cloud to activate the FortiSASE subscription and provision the FortiSASE tunnel. Once connected, all traffic from the endpoint flows through the FortiSASE tunnel to the FortiSASE Security POP, which stands for Point of Presence. The Security POP applies the configured security policies, inspecting traffic for threats before allowing it to read the Internet. The FortiClient Cloud component plays a crucial role in the endpoint management service, handling license activation, endpoint registration, and policy distribution. This integration allows administrators to read logs in FortiSASE and modify configurations as needed. This mode requires FortiSASE user-based licensing and supports configuring Zero Trust Network Access, known as ZTNA. In ZTNA deployments, FortiSASE joins the Fortinet security fabric to share endpoint information with FortiGate devices, enabling corporate firewalls to implement ZTNA for remote users already registered to FortiSASE. FortiSASE Use Cases Overview. FortiSASE implements several flexible steering methods to redirect network traffic from the user edge to the FortiSASE security infrastructure. These steering methods enable three primary use cases that address different security requirements. Looking at the diagram, let me explain each use case and the steering methods that support them. Secure Internet Access, abbreviated as SIA, provides secure access to Internet and web-based applications. This use case can be implemented using multiple steering methods. The agent method using FortiClient provides the most comprehensive protection with an always-on tunnel. IPsec with routing, which includes thin edge and branch on-ramp options, allows network devices to route traffic to FortiSASE. IPsec with explicit proxy, known as private proxy, combines IPsec tunneling with proxy functionality. The agentless proxy method allows users to configure their browsers to use FortiSASE directly. Secure Private Access, abbreviated as SPA, enables secure access to private applications hosted behind SPA hubs in corporate data centers. The same steering methods support SPA, routing traffic through FortiSASE to read internal corporate resources securely. This is particularly valuable for remote workers who need to access on-premises applications. Secure Software as a Service Access, abbreviated as SSA, provides secure access to software as a service applications through Cloud Access Security Broker, or CASB, integration. FortiSASE offers both inline CASB for real-time inspection and API-based CASB for deeper cloud application monitoring and control. Each steering method has specific deployment requirements and advantages. The choice depends on factors such as device management capability, network architecture, and security requirements. Security Points of Presence Architecture. The security points of presence, commonly referred to as POPs, form the backbone of FortiSASE infrastructure. Understanding this architecture is crucial for optimizing performance and compliance. Looking at the architecture diagram, let me walk you through how traffic flows through the Fortinet SASE infrastructure. Remote users connect through various methods including FortiClient agent tunnels, proxy configurations, or edge devices. Their connection is automatically directed to the nearest available security POP based on geographic proximity and network latency. The security POP contains the core FortiSASE security inspection capabilities. All security features including antivirus, IPS, web filter, DLP, and application control are applied at this layer. Each security POP can handle traffic from multiple remote users while maintaining consistent security policy enforcement. The endpoint management point of presence handles FortiClient registration, license validation, and endpoint policy distribution. This component works with FortiClient Cloud to manage the lifecycle of managed endpoints. The logging POP aggregates logs from all components for centralized visibility and reporting. Administrators can forward logs to external servers, configure log retention policies, and enable log anonymization as needed. The Internet Gateway at each security point of presence handles traffic destined for the public Internet after security inspection. For customers with dedicated public IP addresses, this provides consistent source IP identification. For secure private access deployments, the SPA hub connection allows traffic to flow to corporate data centers through IPsec tunnels with BGP routing. The number of security point of presence accessible to your organization depends on your subscription tier and user count. Selecting point of presences closer to your remote users improves redundancy and reduces latency for tunnel connections. Secure Private Access Overview. Secure Private Access, or SPA, enables FortiSASE remote users to securely access private TCP-based and UDP-based applications hosted behind corporate FortiGate hubs. Let me explain how this architecture works. Looking at the diagram, the topology follows a hub-and-spoke model where FortiSASE security POPs act as spokes connecting to FortiGate hub devices in corporate data centers. Remote users connect to FortiSASE security points of presence through their FortiClient tunnel or other supported connection methods. The security point of presence handles security inspection and then determines the traffic destination. For traffic destined for private corporate resources, the security POP establishes an IPsec tunnel to the FortiGate hub. Border Gateway Protocol routing is used to exchange route information between security POPs and the hub, ensuring proper traffic forwarding. The FortiGate hub sits in the corporate data center and provides connectivity to private resources on the internal LAN. This could be an SD-WAN hub or a standalone FortiSASE SPA hub converted from a next-generation firewall. FortiSASE supports the Fortinet Auto Discovery VPN, or ADVPN, configuration. ADVPN allows the traditional hub and spoke topology's spokes to establish dynamic, on-demand, direct tunnels known as shortcut tunnels between each other. This avoids routing through the hub device for spoke-to-spoke communication. The SPA architecture supports traffic flow in both directions. Remote agents can access resources behind FortiGate hubs, and FortiGate hubs can initiate connections to remote agents for specific use cases. FortiSASE supports up to 12 FortiGate hubs for SPA deployments, providing flexibility for organizations with multiple data centers or regional requirements. Each hub requires an SPA subscription and must be registered in the same FortiCloud account as FortiSASE. FortiSASE monitoring capabilities. FortiSASE provides comprehensive monitoring capabilities through dashboards and monitors that enable administrators to track device inventory, security threats, traffic patterns, and network health. The status dashboard provides an overview of the current FortiSASE environment and endpoint status. It displays connected users, edge devices, and their connection states. The security dashboard shows the status of security features for internet access and private access traffic. It includes a vulnerability summary widget that displays detected vulnerabilities on managed endpoints, categorized by severity level. Administrators can read down on vulnerabilities to view affected endpoints and schedule automatic patching for selected vulnerabilities. FortiView provides a comprehensive monitoring system that integrates real-time and historical data into a single view. Multiple FortiView monitors are available, including sources, which displays traffic sources by volume. Edge devices shows edge device traffic patterns. Destinations tracks traffic destinations. Applications monitors application usage. Inline CASB detects cloud applications through application control. Websites tracks website access by session count. Policies shows policy usage. Sessions displays traffic sessions by source. VPN monitors tunnel connections by user. And threats displays detected threats with drill down capability. For a PI-based CASB, dedicated monitoring pages show an overview of connected cloud applications, applications connection status, files being monitored, and alarms triggered by policy violations. Digital Experience Monitoring, or DM, provides visibility into endpoint to security point of presence connectivity, software as a service application health, and network performance metrics. DM can trace end-to-end network performance from an endpoint through the security point of presence to software as a service applications. Administrators can create custom dashboards and monitors by adding widgets and applying filters to focus on specific data relevant to their operational needs. Endpoint Management Overview. Welcome back. In this section, we will explore the endpoint management capabilities of FortiSASE, which provide comprehensive control over FortiClient managed endpoints. Endpoint management in FortiSASE allows administrators to view and manage all FortiClient endpoints that have registered with the FortiSASE Endpoint Management Service. This includes both managed endpoints that are actively receiving policies and unmanaged endpoints that have been excluded from management. The Endpoints page, accessible from Operations, Connectivity, Endpoints, displays a list of endpoints with detailed information. This includes the device username, which identifies the local user account on the endpoint. The authenticated username shows the user who authenticated to FortiSASE. The endpoint management status indicates whether the device is open or offline. The security POP connection status shows which point of presence the endpoint is connected to. Additional information includes the source IP, which is the public IP address of the endpoint. The FortiSASE tunnel IP address is the internal IP assigned within the FortiSASE tunnel. The FortiSASE agent session provides session details. The platform indicates the operating system. Vulnerabilities detected show security issues found on the endpoint. The FortiClient version and ID help track software versions. Zero Trust Network Access tags show applied security posture tags. The profile indicates which endpoint profile is applied. And last seen shows when the endpoint last communicated with FortiSASE. Administrators can toggle between managed endpoints and unmanaged endpoints views to see devices in different management states. Security posture tags and tagging rules. Security posture tags are a powerful feature in FortiSASE that enable dynamic endpoint classification based on their security state. These tags can be used in policies to implement zero-trust access controls. Looking at the tagging workflow, the process begins with endpoints connecting to FortiSASE. The FortiSASE Endpoint Management Service continuously evaluates each endpoint against configured tagging rules. Tagging rules define the conditions that must be met for a tag to be applied. FortiSASE supports several types of tagging rules. Antivirus rules check if the endpoint has antivirus software installed and whether definitions are current. Vulnerability rules evaluate whether the endpoint has known common vulnerabilities and exposures or security vulnerabilities. OS version rules verify the operating system version meets requirements. Certificate rules check for the presence of required certificates. Custom rules allow administrators to define specific conditions using logical operators. When an endpoint meets the conditions of a tagging rule, the corresponding security posture tag is applied. Tags are evaluated continuously, so as endpoint state changes, tags are added or removed dynamically. These tags then feed into access policies configured in FortiSASE. Policies can reference tags to allow or deny access based on endpoint security posture. For example, you might require endpoints to have an up-to-date antivirus tag before allowing access to sensitive applications. The end result is access decisions that are dynamically enforced based on the real-time security state of each endpoint. This implements a true zero-trust approach where access is continuously validated rather than granted once at login. FortiSASE 25.3.148 introduces enhanced tagging capabilities including CVE-based tagging, negation logic to identify non-vulnerable devices, and the ability to combine multiple rules using logical and sign or sign operators. Creating SPA service connections. After configuring the network settings, you can create service connections, which represent the IPsec tunnels to your FortiGate hubs. Let me walk through the configuration process. Looking at the service connection creation flow, you begin by accessing operations, connectivity, secure private access and clicking Create to add a new service connection. If you are using FortiOS 7.4.5 or later with Fabric Overlay Orchestrator, you can use an easy configuration key to automatically populate many fields. This key is generated on the FortiGate hub and can be pasted into FortiSASE to simplify setup. To use the key, your BGP routing design must be set to BGP per overlay, hub selection method must be hub health and priority, and authentication method must be pre-shared key. For manual configuration, you need to provide several parameters. The name is an alias for the hub connection, with a maximum of 25 alphanumeric characters, spaces, and dashes. The autonomous system number is only configurable if multi-ASN support is enabled, allowing you to specify the ASN of this particular hub. The remote gateway is the public IP address for the IPsec connection to the hub. The authentication method can be either pre-shared key, which is the default and requires specifying a PSK that matches the hub configuration, or certificate, which requires selecting a PKI user and certificate for mutual authentication. The BGP peer IP is the IP address used as the BGP peer ID on the hub. For BGP per overlay, this should be an IPsec interface on the FortiGate hub. For BGP on loopback, this should be a loopback interface on the hub. The network overlay ID must be unique for each hub. This prevents conflicts if an active hub triggers a shortcut between spokes and there is a failover to another hub. After configuration, FortiSASE establishes the connection and the configuration state changes from creating to success. Security Policies Overview. Security policies in FortiSASE control how traffic is inspected and what actions are taken. FortiSASE provides different policy types for different traffic flows. Looking at the policy architecture, Traffic from endpoints first flows through the FortiSASE security POP where policy evaluation occurs. Secure Internet Access Policies, found under Security, Policies, Secure Internet Access, control traffic destined for the public Internet. These policies define source criteria including users, groups, and security posture tags. Destination criteria can include addresses, services, and applications. The action specifies whether to allow or deny the traffic. Security profile groups define which security features inspect the traffic, including antivirus, web filter, IPS, DLP, and application control. Secure Private Access Policies control traffic to and from SPA hubs. These are divided into three categories. To hubs policies control traffic from endpoints destined for resources behind FortiGate hubs. From hubs policies control traffic initiated from hub networks toward endpoints. Endpoint-to-endpoint policies control direct communication between endpoints connected to the same security POP when endpoint-to-endpoint traffic is enabled. Proxy policies, found under Security, Policies, Proxy, specifically control traffic from agentless proxy users. These policies apply to browser-initiated sessions that pass through the FortiSASE proxy service. Default policies are created automatically and provide baseline security. However, administrators typically create additional policies to implement granular controls based on user identity, destination, application, or endpoint security posture. Policies are evaluated in order, with the first matching policy determining the action. This makes policy ordering important for achieving desired security outcomes. User authentication methods. FortiSASE supports multiple authentication methods to verify user identity before granting access. The choice of authentication method depends on your existing identity infrastructure and security requirements. Looking at the authentication options, let me explain each method available in FortiSASE. Local users are created directly in FortiSASE. This is suitable for small deployments or testing, but does not scale well for large organizations. Local users authenticate with credentials stored in FortiSASE. LDAP integration allows FortiSASE to authenticate users against your existing LDAP directory, typically Active Directory. You configure the LDAP server connection including server address, bind credentials, and user search base. FortiSASE can read group membership for policy-based access control. Note that for instances with network restrictions removed, LDAP servers with internal IP addresses require SPA hub configuration with BGP per overlay for connectivity. Radius integration provides authentication through Radius servers. This is useful when you have existing Radius infrastructure or need to integrate with multi-factor authentication solutions that support Radius. SAML Single Sign-On allows integration with identity providers like Microsoft Azure Active Directory ID, Okta, ADFS, and FortiAuthenticator. SAML SSO provides a seamless authentication experience where users authenticate with their corporate credentials. FortiSASE acts as the service provider and receives authentication assertions from the identity provider. User group information can be retrieved from the SAML assertion for group-based policies. Fortinet Single Sign-On, or FSSO, enables FortiSASE to use FSSO records from collector agents. This allows users authenticated to the Windows domain to access FortiSASE protected resources without re-authentication. FSSO requires either FortiAuthenticator or an independent collector agent installed on Windows domain controllers. PKI authentication uses client certificates for authentication, providing strong cryptographic identity verification. SAML SSO configuration with Microsoft Entra ID. Configuring SAML Single Sign-On with Microsoft Entra ID, formerly known as Azure Active Directory, is a common integration for FortiSASE deployments. Let me walk through the key configuration steps and considerations. The integration involves configuring both Microsoft Entra ID as the identity provider and FortiSASE as the service provider. Looking at the authentication flow diagram, the process involves multiple exchanges between the components. When a user initiates authentication, either through FortiClient or the proxy, FortiSASE redirects the request to Microsoft Entra ID. The user authenticates using their corporate credentials, potentially including multi-factor authentication if configured in Entra ID. Upon successful authentication, Entra ID generates a SAML assertion containing user identity and group membership information. This assertion is sent back to FortiSASE, which validates the signature and extracts user information. FortiSASE then uses the authenticated identity and group membership for policy evaluation, determining what resources the user can access. The configuration in FortiSASE requires several SAML configuration fields. The entity ID uniquely identifies FortiSASE to Entra ID. The assertion consumer service URL is where Entra ID sends the SAML response. The single logout service URL handles logout requests. The IDP certificate is used to validate SAML assertion signatures. In Microsoft Azure Active Directory, you create an enterprise application for FortiSASE, configure the SAML settings with FortiSASE U or LOS, define attribute mappings for user identity and groups, and assign users or groups who can access FortiSASE. FortiSASE supports searching user groups from the SAML IDP to automatically populate group membership for policy configuration. You can also test the SSO configuration directly from FortiSASE to verify the integration before deploying to users. With dedicated IP addresses and Microsoft Entra ID conditional access policies, you should define the IPv4 address ranges of your dedicated IP addresses in those policies to properly control access to Entra ID cloud resources for FortiSASE users. Edge Devices Overview. Welcome back. In this section, we will explore the edge device capabilities of FortiSASE, which extend security protection to branch locations and remote sites without requiring FortiClient on every endpoint. FortiSASE supports three types of edge devices that can connect to the FortiSASE infrastructure. FortiExtender devices provide cellular and wired connectivity options for remote sites. FortiGate devices can act as thin edge devices routing traffic to FortiSASE. FortiAP wireless access points can connect directly to FortiSASE to secure wireless clients. Looking at the edge device architecture, each device type establishes a secure connection to FortiSASE security POPs. FortiExtender uses IPsec tunnels to connect remote locations, providing secure internet access for all devices at that site. FortiGate thin edge devices route traffic through FortiSASE rather than inspecting it locally, leveraging FortiSASE's cloud-based security stack. FortiAP devices use CapWap tunnels to connect wireless clients through FortiSASE for security inspection. Edge devices must be registered in the same FortiCloud account as your FortiSASE instance and require appropriate licensing. The edge device subscription is separate from the remote user subscription. You can monitor edge devices from the status dashboard using the Edge Devices widget, which shows online status, connected security POPs, and subscription entitlements. The FortiView Edge Devices Monitor provides detailed traffic analysis for each edge device. Edge device traffic is subject to the same security policies as agent-based traffic, allowing consistent security enforcement across all connection methods. FortiAP Edge Device Configuration. FortiAP wireless access points can connect directly to FortiSASE, providing secure wireless access without requiring a local FortiGate controller. This is particularly useful for distributed locations that need wireless connectivity with centralized security. FortiSASE 25.3.148 adds support for FortiAP devices in the FortiAP 441K series, expanding the range of compatible hardware. The configuration options have also been enhanced to streamline the FortiAP setup process. Looking at the FortiAP deployment architecture, the access point uses CAPWAP, which stands for Control and Provisioning of Wireless Access Points Protocol, to establish a tunnel to FortiSASE. CAPWAP uses UDP port 5246 for the control channel. Wireless clients connect to the FortiAP's configured SSIDs. The traffic from these clients is encapsulated and sent through the CAPWAP tunnel to the FortiSASE security POP. At the security POP, FortiSASE applies security policies to the wireless client traffic. This includes all the security features available in FortiSASE, such as antivirus, web filter, IPS, and application control. FortiAP configuration in FortiSASE includes SSID settings with various security modes. WPA2 Enterprise and WPA3 Enterprise-only modes support user authentication, which allows the user column in wireless client views to display authenticated user information. Captive portal-only mode also provides user identification after authentication. You can view connected wireless clients from Operations, Connectivity, Connected Wireless Clients. This view shows client details and allows you to drill down into FortiView for session analysis or Wi-Fi client traffic patterns. The Fortinet AP Edge device requires a separate FortiSASE subscription for Fortinet AP Edge device support. Domain Name System Configuration and Redirection Rules. Domain Name System Configuration in FortiSASE controls how domain name system resolution is handled for connected users and devices. This includes both the domain name system servers used for resolution and domain name system redirection rules for split domain name system scenarios. Under Network, DNS, you can configure the DNS servers that FortiSASE uses for resolution. You can use FortiSASE's default DNS servers, specify custom DNS servers, or use DNS servers provided by your SPA hubs for internal name resolution. Domain Name System Redirection Rules, also known as Split Domain Name System, allow you to direct domain name system queries for specific domains to designated domain name system servers. This is particularly useful when you have internal domains that should be resolved by internal domain name system servers behind an SPA hub rather than public domain name system. Looking at the DNS flow, when a connected user or device makes a DNS query, FortiSASE evaluates the query against configured redirection roles. If the domain matches a redirection role, the query is forwarded to the specified DNS server. For internal domains, this typically means routing the query through the SPA tunnel to an internal DNS server. If no redirection role matches, the query goes to the default DNS servers configured in FortiSASE. FortiSASE 25.3.148 introduces transparent DNS redirection, where split DNS rules transparently apply to all pass-through traffic for FortiClient agent tunnels including mobile clients, edge device clients, and proxy clients. This simplifies DNS configuration by automatically applying rules without requiring client-side configuration. Domain name system filter security profiles can also be applied to domain name system traffic, blocking resolution of malicious or unwanted domains based on FortiGuard category ratings or custom block lists. Digital Experience Monitoring Deep Dive. Digital Experience Monitoring, or DEM, provides visibility into the end-to-end network performance from endpoints through FortiSASE to software as a service applications and other destinations. This helps administrators diagnose connectivity issues and understand user experience. DEM requires an advanced or comprehensive subscription for full functionality. Standard and not for resale subscriptions can opt into a free 90-day trial with DEM activated on up to 10 endpoints. The DEM agent is packaged with the FortiClient installer for new FortiSASE instances. For existing instances, endpoints are prompted to upgrade to a FortiClient version that includes the DEM agent. Looking at the DEM architecture, the DEM agent installed on the endpoint collects performance metrics and initiates trace jobs. The agent connects to FortiSASE and reports metrics including network bandwidth usage, CPU and memory utilization, and hard disk usage on the endpoint. When a trace job is initiated, the DEM agent sends probe packets through the network path to the target destination. This traces the route from the endpoint through the security POP to the software as a service application or other destination. FortiSASE collects and displays the results, showing average round-trip time and packet loss for each hop along the path. This helps identify where network issues are occurring, whether in the LAN network, the connection to FortiSASE, or beyond the security POP. The trace job output helps identify performance bottlenecks. When an endpoint is connected to the FortiSASE tunnel, the first and second hops are typically the entry and exit interface IP addresses of the security POP. Remaining hops show the path through various ISPs to the destination. Some ISPs may not respond to probe packets, showing as timeouts in the results. SPA Hub Monitoring. SPA Hub Monitoring provides visibility into the health and performance of secure private access service connections. This feature is included with all FortiSASE remote user subscription types and does not require a separate subscription. SPA Hub Monitoring is accessible from Operations, Connectivity, Digital Experience Monitoring under the SPA Hub Monitoring tab. Each FortiSASE security POP sends periodic ICMP probes to the HealthCheck IP configured for each SPA hub to measure SLA metrics including jitter, latency, and packet loss. Looking at the monitoring views, two perspectives are available. The SLA by Security POP view displays historical SLA data for all SPA service connections associated with a selected security POP. This provides a security POP-centric perspective for analyzing performance of multiple service connections from a specific POP. The SLA by Service Connection view offers a service connection-centric perspective, showing SLA history across all security POPs for a specific SPA service connection. This is useful for tracking performance inconsistencies or degradations across different POPs for the same hub. SLA metrics are displayed for the most recent 10 minutes using a heat map visualization. Each rectangular grid represents a 1-minute time slice. Hovering over affected grids and clicking View Details displays detailed graphs showing latency, jitter, and packet loss for the selected time period. A dotted yellow line on the graphs represents the configured threshold for each metric. If SLA metric data is missing or not displayed for a particular service connection, you should verify that the HealthCheck IP is reachable from FortiSASE security POPs and that the device associated with the HealthCheck IP is configured to respond to ICMP echo requests. SLA thresholds can be edited to match your organization's requirements for acceptable performance levels. IP management and IPAM. IP management in FortiSASE controls how IP addresses are allocated to connected users and devices, as well as the public IP addresses used for outbound traffic. Understanding these settings is important for network planning and integration with existing infrastructure. Under Network IP Management, you can configure several IP-related settings. The Public IP section shows the dedicated public IP addresses assigned to your FortiSASE security POPs if you have a subscription tier that includes dedicated IPs. These addresses are used as the source IP for outbound internet traffic from your remote users. The IPAM section controls the private IP address pools used for FortiClient tunnels and edge device connections. FortiSASE assigns addresses from these pools to connected clients. The default pool is 100.65.0.0/16, but you can configure alternative pools from the following ranges: 10.0.0.0/8, 100.64.0.0/10, 172.16.0.0/12, or 192.168.0.0/16. FortiSASE 25.3.148 introduces an IPAM usage chart that displays IP address utilization information, helping you monitor pool consumption and plan for capacity. Remote agent and edge device user identification is enabled by default on new instances. This feature assigns unique IP address ranges per security POP, allowing you to identify specific users in traffic logs. It also removes source NAT for traffic destined for SPA hubs, preserving the original client IP for logging and access control on hub-side resources. When configuring IPAM pools, ensure they do not overlap with networks used in your SPA hub configurations or other internal networks. The configured IPAM pools are unavailable for use in your network configuration elsewhere. Geofencing and regional compliance settings can restrict which security POPs users connect to based on geographic requirements. Source IP anchoring allows you to associate users from specific regions or groups with particular public IP addresses for consistent source identification. API-based CASB overview. Welcome back. In this section, we will explore the API-based Cloud Access Security Broker, or CASB, capabilities integrated into FortiSASE. This feature provides deep visibility and control over cloud application usage beyond what inline inspection can achieve. While inline CASB through application control inspects traffic as it passes through FortiSASE, API-based CASB connects directly to cloud application APIs to monitor and protect data at rest and user activities within those applications. Looking at the API-based CASB architecture, FortiSASE connects to supported cloud applications through their native APIs. This connection allows FortiSASE to monitor files stored in cloud storage, track user activities within applications, and enforce data protection policies. The API-based CASB feature currently supports 3 cloud applications. AWS S3 provides visibility into files stored in Amazon AWS S3 buckets. Google Cloud Storage enables monitoring of files in Google Cloud Storage. Office 365 provides comprehensive monitoring of Microsoft 365 services including SharePoint, OneDrive, and Exchange. To use API-based CASB, you must first onboard each cloud application by establishing the API connection. This typically involves configuring OAuth authentication or API credentials in the cloud application and providing those credentials to FortiSASE. Once connected, FortiSASE pulls file inventory from the cloud application and begins monitoring for policy violations. The Files page shows all monitored files, and the Alerts page displays policy violations triggered by user activity. API-based CASB management and protection are integrated directly into FortiSASE, accessible from Security. API-based CASB, applications for configuration and monitoring, dashboards, API-based CASB for visibility. Central management with FortiManager. FortiSASE integrates with FortiManager to provide centralized management capabilities. This integration allows organizations to manage both their on-premise FortiGate devices and FortiSASE remote user security from a single management platform. Central management is a select availability feature that must be enabled by FortiCare support. Once enabled, you can synchronize a selected set of configuration settings from FortiManager to FortiSASE. Looking at the central management architecture, FortiManager serves as the central configuration repository. Administrators configure objects in FortiManager, including addresses, address groups, security profiles, and policies. These objects are then synchronized one way from FortiManager to FortiSASE. The synchronization supports numerous configuration elements. Policy packages including firewall policies, proxy policies, schedules, and security posture tags can be synchronized. security profile groups with secure sockets layer inspection, antivirus, web filter, IPS, file filter, DLP, DNS filter, application control, and video filter profiles are supported. Firewall addresses and address groups, services and service groups, local PKI and LDAP users and user groups, and authentication sources for LDAP and Radius can all be managed centrally. FortiManager version requirements depend on what you want to synchronize. FortiManager 7.4.4 or later is required for synchronizing configuration settings other than policy packages. FortiManager 7.6.4 or later is required for synchronizing policy packages. An important consideration is that central management supports only one-way synchronization from FortiManager to FortiSASE. Objects synchronized from FortiManager become read-only in FortiSASE and cannot be modified directly in the FortiSASE portal. You should avoid deleting objects from FortiManager to prevent conflicts. Central management supports synchronizing a maximum of 3,000 objects at once from FortiManager. Remote browser isolation. Remote browser isolation, commonly abbreviated as RBI, is an advanced security feature available with the comprehensive FortiSASE subscription. RBI provides an additional layer of protection by rendering web content in an isolated cloud environment rather than on the user's endpoint. Looking at the RBI architecture, when a user accesses a website configured for isolation, the request is redirected to the RBI service instead of being processed directly. The RBI service runs a browser in an isolated cloud container that fetches and renders the web content. Only the visual representation, essentially a safe video stream of the rendered content, is sent back to the user's browser. This approach provides several security benefits. Malicious code cannot execute on the endpoint because actual web content never reaches the user's device. Zero-day exploits targeting browsers are neutralized in the isolated environment. Drive-by downloads and malicious scripts are contained within the isolation container. Even if a website is compromised, the user's device remains protected. RBI can be configured to isolate traffic based on various criteria. You can isolate all uncategorized websites, which is useful for protecting against new or unknown threats. Specific web categories can be configured for isolation, allowing you to target high-risk categories while allowing trusted categories to be accessed directly. Individual URLs or domains can be explicitly configured for isolation. RBI integrates with the proxy configuration in FortiSASE. When proxy is enabled, you can configure which traffic should be redirected to RBI based on web filter categories or custom rules. The user experience with RBI is largely transparent. Users interact with websites normally, but the actual rendering happens in the cloud. Some interactive features may have slight latency compared to direct browsing, but modern RBI implementations minimize this impact. Managed endpoint client onboarding. Client onboarding is the process of getting FortiClient installed and connected to FortiSASE on user endpoints. FortiSASE provides several methods to streamline this process for managed endpoints. The basic onboarding workflow starts with the administrator generating an invitation code in FortiSASE. This code is used by FortiClient to connect to the FortiSASE endpoint management service. The administrator then distributes FortiClient installers and the invitation code to end users. End users install FortiClient on their endpoints and enter the invitation code to register with FortiSASE. Upon successful registration, FortiClient receives the endpoint profile configuration and establishes the FortiSASE tunnel. FortiSASE provides pre-configured installers that include the invitation code, simplifying the end-user experience. These installers are available for download from the FortiSASE portal under Access and Authentication, Access, Users and Groups, Onboard Users. For enterprise deployments, FortiClient can be deployed through enterprise mobility management solutions like Microsoft Intune. The FortiClient installer package is uploaded to the EMM platform, and the invitation code is configured in the deployment profile. The EMM automatically pushes FortiClient to managed devices. FortiSASE 25.3.148 introduces authenticated onboarding as a select availability feature. When enabled, users must authenticate via SAML single sign-on during the onboarding process. This ensures only authenticated users from your identity provider can register endpoints with FortiSASE, preventing unauthorized devices from connecting even if they have a valid invitation code. With authenticated onboarding, a new invitation code is generated that requires authentication. All previously managed endpoints are automatically migrated to use the new code, and pre-configured installers are updated with the new code. Troubleshooting common issues. Let me cover some common issues you may encounter with FortiSASE and how to troubleshoot them. For security POP provisioning issues, if you receive the error 21400.4 failed to configure security POP during initial provisioning of a new instance, this typically indicates a back-end configuration issue. You should contact FortiCare support with the error details for assistance. If you see the notification background provisioning for a specific security POP is still in progress, please check back later. This is normal during initial setup. Security POP provisioning can take some time, and you should wait for the process to complete before expecting full functionality. For endpoint connection issues, verify that the endpoint has the correct invitation code. Check that FortiClient is the correct version and properly installed. Ensure the endpoint has internet connectivity and can read FortiSASE services. Review the endpoint management status in FortiSASE to see if the endpoint is registered. When endpoints are connecting to a security POP that is not the closest geographically, this is typically due to DNS-based load balancing or anycast routing selecting a POP based on network path rather than physical location. Check the latency to different POPs using the Appendix C tunnel performance guidance to evaluate if the selected POP provides acceptable performance. For SPA connectivity issues, verify that the HealthCheck IP is reachable and responding to ICMP. Check the IPsec tunnel status in both FortiSASE and the FortiGate hub. Verify BGP peering is established and routes are being exchanged. Read the SPA hub monitoring for SLA metrics that might indicate connectivity problems. For authentication issues, verify the authentication source configuration, whether LDAP, Radius, or SAML. Test the SSO configuration from FortiSASE to verify the IDP integration. Check that user group mappings are correctly configured for policy matching. FortiSASE best practices in summary. As we conclude this presentation, let me summarize some best practices for FortiSASE deployment and administration. For subscription planning, evaluate your user count and required features to select the appropriate subscription tier. Remember that Standard provides core security, Advanced adds dedicated IPs and full DEM, and Comprehensive includes RBI. Consider FortiFlex for flexible licensing needs. For security point of presence selection, choose points of presence geographically close to your user populations to minimize latency. The number of points of presence available depends on your subscription tier and user count. Use the asset map to visualize point of presence locations relative to your users. For security policy design, start with the default policies and customize based on your requirements. Use security profile groups to bundle inspection features for consistent application. Leverage security posture tags for zero trust access controls based on endpoint state. For authentication, integrate with your existing identity provider using SAML single sign-on for seamless user experience. Consider enabling authenticated onboarding to ensure only authorized users can register endpoints. Use group-based policies to apply different access controls to different user populations. For SPA deployments, follow Fortinet's SD-WAN best practices for hub configuration. Use BGP recursive routing for hub redundancy. Monitor SPA Hub Health using the built-in SLA monitoring features. For monitoring and operations, regularly read the security dashboard for vulnerability status and security events. Use FortiView monitors to understand traffic patterns and identify anomalies. Set up log forwarding to your SIEM for long-term retention and correlation. For endpoint management, use endpoint profiles to standardize configurations across user populations. Enable vulnerability scanning and automatic patching for endpoint security hygiene. Monitor endpoint status and investigate disconnected endpoints promptly. Thank you for your attendance. Please consider subscribing to the channel and liking this video.